Hi everyone. We're going to finish up a few last thoughts on solving systems of equations. So we started off by talking about three different types of systems. Consistent and independent was where we only had one solution, right? If we looked at the graph, it's where the two lines intersect. We also had consistent and dependent, and this is where we had two lines that overlapped each other, right? It's really like just the same line. And then we had inconsistent systems where our two lines were parallel and they never intersected. Now we really only saw, when we were doing either the substitution or the elimination methods, we only saw systems that were both consistent and independent. We did not have any examples that were consistent and dependent or inconsistent. Right? And so now I'm going to finish a few last thoughts, a few final thoughts on what if we were solving equations, or excuse me, systems, where the solutions were either consistent and dependent or maybe even inconsistent. And so what's going to happen is, if we're ever solving a system by either substitution or elimination, it doesn't matter, but if we ever get to a point where we get something like 0 equals 0, or maybe 10 equals 10, or perhaps x equals x, then that is going to give us an infinite number of solutions, right? Because 0 always equals 0 no matter what, and x always equals x, right? Any number equals itself all the time. And that would give us an infinite number of solutions, which would be consistent and dependent. Right? Whenever we get something like 0 equals 0 or 108 equals 108, whatever we're looking at, if we have a number that equals itself, then that means that system would be consistent and dependent. If we had a system where we eventually reduce down to something like, let's say, 0 equals 2, or 1 equals 5, or whatever the case is, that means there would be no solution, which means our system would be inconsistent. Oops. My pen. Whoops. Okay. So we never actually saw examples of this yet. All we did thus far was look at systems that came out to be consistent and independent. Now let's look at a couple examples that are going to come out to be either consistent and dependent or inconsistent, so we can kind of see how that plays out. So here I have a system, a negative 2x minus 6y equals 28, and 5x plus 15y equals negative 24. So let's go ahead and solve this system using either of the methods that we prefer, either substitution or elimination. And let's see what we get. I'm not seeing a super easy way to do substitution. I suppose I could do substitution. I'm going to go ahead and try elimination. That is my preferred method. So what I'm going to do is I'm going to think I need to eliminate, let's eliminate my x's for a change. So I'm thinking, what numbers do both 2 and 5 go into? And I think that I need to multiply both the top and bottom equations by something that has my x's match up. And so I'm thinking, let's multiply the top by, how about 5? Right? And let's multiply the bottom by negative 2. By negative 2. Right? And so I chose these numbers because, as you can see, this negative 2 is in front of the x, so I'm multiplying the bottom by negative 2. The 5 was in front of the x on the bottom equation, and I'm multiplying the top equation by 5. When I do this, this guarantees that my x terms are going to match up. Right? They're going to have the same number in front of each of them. So when I simplify here, let's go ahead and distribute on the top equation. Let's go ahead and distribute this 5 through. So in the top equation, I'm going to get 5 times negative 2x. It's going to get me negative 10x. And then 5 times negative 6y is going to get me negative 30y. And then 28 times 5 over here is going to get me a 140. On the bottom equation, I'll distribute that negative 2 through. So negative 2 times 5x is going to get me a negative 10x. Negative 2 times 15y is going to get me a minus 30y. And and then negative 24 times negative 2 is going to get me a positive 48. Okay. So now I see that my x terms match up. So let's go ahead and subtract the entire bottom equation. And when I do this, I have negative 10x minus negative 10x. And this comes out to be 0x. And then when I subtract my y's, I have negative 30y minus negative 30y. And that also comes out to be a 0y. And then lastly, I have a 140 minus 48, and that comes out to be 92. So in this system, when I reduce even further, 0x plus 0y, well, this is just 0. There's nothing left over there. So on the left side, I have 0, and on the right side, I have 92. So 0 equals 92. Well, does 0 ever equal 92? No, it does not. Right? 0 never equals 92. Therefore, this system, this negative 2x minus 6y equals 28, 5x plus 15y equals negative 24, this whole system right here is inconsistent. Meaning that we have no solutions. Right? This system is inconsistent and there are no solutions. And I know that because after I did my algebra, I get 0 equals 92, which is not true, right? This is not a true statement. Not true. Right here, 0 does not equal 92. Okay, so I know that this is an inconsistent system. Let's try another one. So here I have negative 3a minus 8b equals 12, and 12a plus 32b equals negative 48. Let's see, I'm going to expand this a little bit. Okay. So let's see. I need to eliminate one of my variables, either the a or the b's. And so what I see is, hey, on the top I have a negative 3a, and on the bottom I have a 12a. I think negative 3 goes into 12. Okay. So let's go ahead and match up our a's together. Right? I need to multiply the top equation by a number. Well, negative 3 times what gets me negative 12? Sorry, negative 3 times what gets me positive 12? Well, that would be negative 4. So let's multiply the top and bottom equation by 4. So when I multiply that top equation by negative 4, distribute that negative 4 through, and I get negative 4 times negative 3a is a 12a, and negative 4 times negative 8b is a plus 32b, and 12 times negative 4 is negative 48. Okay. And then let's also rewrite the bottom equation here. So 12a plus 32b equals negative 48. And I think we can see what's about to happen. We're trying to reduce our a's out, so let's go ahead and subtract that bottom equation. When I do that, I have 12a minus 12a, which is 0. Plus 32b minus 32b is another 0b. And then equals negative 48 minus negative 48 is, in fact, 0. When I reduce the left side here, I have 0 equals 0. And so this is a true statement. 0 always equals 0, right? So since 0 always equals 0, that means that this system up here is consistent and dependent. Consistent and dependent. right? Because 0 always equals 0. So no matter what value you sub in for A in the equations, you're going to get the same value for B, right? Because these lines are really the same lines. If I were to graph these, I don't know exactly what they look like. I'm just kind of sketching something. But if I were to graph them, I would have two lines that overlap with each other, right? Because they are really the same line, because 0 always equals 0. That's always true. So because this is a consistent and dependent system, that means my solution, I guess, is all real numbers. All real numbers. Wonderful.